let me
We're
know when you're
live.
on.
Yeah. Hello, everyone. Welcome to the last AEZ Hackathon workshop series. We are very gracefully standing at almost at the end of the hackathon with a total prize pool of $100K, which also doesn't end there, by the way. There's mentorship plus support from Atom Accelerator, Long Hash, and a lot more that's laid out there for all the developers. Super happy to having hosting this on DoraHacks.io. We're on a roll. We already have very interesting projects that are going that have submitted. So pretty sure going to be a tough call for the team. But yeah, for with that being said, for today's workshop, we have with us Serdar, who's a Devrel engineer at Interchain. Welcome, Serdar. This workshop is going to be about getting started with the IBC fee middleware. So yeah, Serdar, happy to have some opening thoughts from you, and then let's get to the workshop content as well.
Yeah, welcome everyone. As I said, I'm Serdar. I'm the Devrel engineer in Interchain, and today we'll be looking at the relay incentivization problem and the IBC fee middleware, which is a solution to that problem. So, in this workshop, our goal is to go through, um, create a chain from scratch, and then integrate the IBC fee middleware to that chain, and then also integrate it to a front end for that chain, also from scratch. Um, and basically, at the end, you will run a demo where you will run two chains, and then you will do a fee transfer between these chains. So that's the plan for this workshop. It's going to be about 2 hours. There will be a 10-minute break in the middle. This link that I'm looking at right now should have been shared with you, so you can go to this link and follow along. This is a guided coding session, but before I start, I will, of course, give a presentation to introduce you to the problem so you can understand what we are trying to solve with this problem. Let me
Perfect. Yeah.
oh,
Also,
yeah, let me see if there are any questions.
yeah, just a heads up for everyone. Also, you watching us today at all these different platforms we're at. Feel free to put any question that you have at any point in the chat, and we'll address it.
Yeah, that's great. Um, okay, so before I start the presentation, I want to say one more thing. That is, if you're at this link and you can see it, you can go to, if you want to follow along and code with me, you can do that. And to do that, you need to have certain dependencies. Maybe you have some of these or all of these already. So if you go to the second page, which is set up your work environment, you can see all the dependencies that are needed and sort of instructions on how to install them. While I'm giving the presentation, you are welcome to install these dependencies. Yeah, I just want to say this now so that when we actually start coding, you can have access to this. This tutorial page is supposed to be also, you can follow it by yourself. So if you feel like it, you can just follow the workshop and do this on your own later. If for example, for hackathon, if you're building a chain, it might be a nice exercise to integrate this fee middleware to your chain so that okay, now you're also supporting relayer incentivization in your chain. So I just want to talk about some potential applications for you as well. Okay, so if there are no questions before we start, I can go. And yeah, it doesn't seem like there are questions. Cool. Right, so the related incentivization problem, I've talked about what we want to learn in this workshop, so let's go to the output. So at the end of it, what we're going to have is basically we're going to have a page like this, where you'll be able to click a send button and be able to send tokens from one chain to another, while also paying a fee to the relayer, as you can see here. So this is our end goal. Okay, so before we can talk about what is the relayer incentivization problem, let's do a quick overview of IBC, right? So you can see that we have like two blockchains here, blockchain A and blockchain B. And the idea is that blockchain A is going to send blockchain B a packet. The very high level overview of what happens is a module in the blockchain A produces some packets, which are essentially just objects that are committed to the consensus storage of the blockchain A. So you can see that on step 4. This is like supposed to symbolize the consensus, and then they're communicating these packets between each other and committing it to their storage. And then the relayer basically queries the chain A and generates a proof for that packet, that the packet is included in the storage of the chain, and then submits that proof to chain B. And then chain B verifies that proof and essentially now handles that packet according to some logic. Okay. Oh, sorry about the diagram's color. I thought I fixed this, but apparently not. But okay. So essentially, this is like sort of like a high-level overview of the packet lifecycle. So everything starts with a send packet message that the user sends, and then there are two things that can happen. One of them is the other chain receives the packet, and the other thing is that the packet times out, which is a timeout path. If the packet times out, then blockchain A gets a message from the relayer that the packet timed out. There's a missing step here, actually, even if you receive the packet. I don't know if anyone can spot the missing step, but if you do so, feel free to type that in the comments before I give the answer. Okay, so the missing step is the acknowledgement step. So even if the chain B receives the packet, it still has to send an acknowledgement to chain A that it has received the packet. So there's another step that's supposed to go on the blue path, which is to acknowledge the packet. And that's required for various reasons, but this is not something that we'll get into right now. Okay, so before we understand, so let's look at how the relayer works, but do this as like from a high level. So from our perspective, the chain, the relayer, and the both chains and the relayer are black boxes, and that's how I drew them. They are black boxes. We don't really care how they work internally, but we just want to look at what kind of messages and what order they send to each other to understand what's happening. So in step one, a user sends a send packet message to chain one, basically saying that, okay, I want to send a packet. And once that packet is sent on chain one, which means that the packet is committed to the storage, the relayer sees that and submits a message to chain two that this packet exists and the proof is here. So this message receive packet contains the proof of the packet, and it's submitted to chain two. And then the chain two does some logic, handles the packet, and then creates an acknowledgement. And the relayer sees that acknowledgement and then submits it back to chain one, so that the chain one knows that the packet has been received. Again, there's actually a missing thing here, even with the messages that are sent in this workflow. I don't know if anyone can see that, but the thing is, when we in IBC, when we usually send these message receive packet and message acknowledgement, we also send it along with a message update client. This is so that the underlying light client, which is basically the proof verifier, is also up to date with the other chain. The message update client also contains a proof that the update is correct, but it's also there. This is not really relevant to our workshop. I just thought I might include it, that it is there. But okay, so this is what happens in a good workflow. Essentially, the relayer basically sends the message receive packet to chain two, and then sends a message acknowledgement to chain one. And there's another possibility, which is that, okay, chain one sends a packet, but chain two maybe is down, or like chain two, for whatever reason, the message can't be relayed to chain two. Maybe the packet itself has some like malformed structures in it, so it just cannot be received by chain two. At that point, we need a message timeout. And the reason why chain one cannot just wait for the timeout and then say, okay, I didn't receive a message acknowledgement, so it must have timed out, is because the chain two might have received it, like right? Because maybe the relayers might be down, even though chain two has received it. So the thing is, message timeout actually contains the proof that the packet was not contained in chain two before a certain time. So that's why the relayer also has to send the message timeout, and the chain one cannot just wait. Are there any questions about this overview of IBC and the relayer? I'll just go check check if there are. Yeah, doesn't seem
Looks like we're good for now.
Okay. This is a high-level overview. Okay, so what is the problem? So what's happening here is basically this relayer is submitting messages, a message receive packet, message acknowledgement, or message timeout. These are just normal SDK messages. There's nothing special about them. What that means is whoever submits them must pay the required fee to execute the custom logic for those messages. So essentially, every time I drew an arrow from the relayer to the chain saying message whatever, the relayer is paying some fee. And on top of that, the relayer is running some infrastructure in order to query both chains, construct a packet with the proofs in them, and send it. So essentially, the relayer is losing money. And the question is, who are paying for the relayers, and why would anyone run a relayer? You can put your thoughts in the chat, like about what you think, who might be paying these fees, and why would anyone run a relayer. But I don't know if anyone knows what's actually happening in practice, because today we have relayers live, and they are relaying messages. So essentially, there must be a reason why they're doing this, right? And the reason is basically either the chains themselves or the foundations belonging to those chains essentially pay the relayers to run. So there's no like a decentralized mechanism. So essentially, some centralized entity, or maybe I don't know if someone has set up a nice incentive structure, but for now, this is not there. So essentially, some foundation or something has to pay these relayers currently, and they do. But of course, we would like this process to be more decentralized, which is what this workshop is about. The fee middleware is a solution to this problem. Okay, so let's look at it from high level, what the fee middleware does and how it works before we actually start implementing it. So, yeah, so, okay, so as I said, so in this case here, we are talking about message transfer. As you can see, message transfer is equal to send packet. So each module will have its own send packet message. For token transfers, that message is called message transfer. So message transfer essentially just creates a packet. But what you do in the fee middleware is you essentially append another message before message transfer, which is called message pay packet fee. And you bundle these into one transaction. And it's submitted. Yeah, and it's submitted to chain A. So you put these two together and submit it to chain A. What happens is essentially a commit, like so in message pay packet fee, you also add some like funds in that message. So you lock up those funds. And the idea is that the relayer who relays these messages will get those funds. So yeah, so let's see if there's something we can follow here. No, okay. So yeah, the idea here is that the way the fee middleware works is you essentially append a message before the transfer message, and that the funds you lock will be get paid to the relayer. So one thing to notice here, yeah, okay. One thing to notice here is that message pay packet fee is submitted on chain A. So what that means is all the fees that are being paid to these relayers are being paid on chain A. So even if there's another relayer wallet on chain B, so even if there's a relayer wallet that's submitting these messages to chain B, the fees for that packet that was submitted to chain B are going to be paid on chain A. So what I'm trying to say is all of the fees that we are going to pay are going to be paid in chain A. Why is that important? Because there are several steps of packet lifecycle. As I said, there's receive packet, there's acknowledgement packet, and maybe there's timeout packet as well. So all of these can be relayed by different relayers. So a receive packet can be made by a relayer A, but then the acknowledgement packet may be relayed by a relayer B. So in this case, both of these relayers need to get some part of the fee, and you cannot just pay to one of them. And they all have to be paid on chain A. So, okay, I guess we can be more specific about what is a middleware quickly. And because, it's called the fee middleware, and what does the middleware part mean? In IBC, we have this concept called middleware. And the idea is that, so let's say there's a base application. In this case, this will be a token transfer application for IBC, let's say. There are other applications as well, like the interchain accounts, but for simplicity, let's just talk about the transfer application. So we have some base application, that base IBC application, which is transfer in this case. And the middleware is basically another application. You can think of it like another application that wraps the base application in it. So from the perspective of the chain, there's like the base application isn't really there anymore in terms of IBC, but the middleware is there. And when core IBC wants to send a message to the base application, it instead sends it to the actual application, which is the middleware. And the middleware receives it, does some logic, and then relays that to the base app. And then so that's what happens. And when base app wants to send a message, it first goes through the middleware and then to core IBC. So here, this is what you can see in that diagram. So it starts at core IBC. The core IBC sends a message. It gets received by a middleware. This picture is showing a middleware of size 2. So the middleware itself can also be wrapped in another middleware. So you can have this middleware stacks where you have multiple middlewares wrapping each other. So in this case, there's 2. So what happens is core IBC sends a message, M prime, and then the middleware sort of modifies that message based on whatever it wants to do. And then the next middleware also modifies it and finally gets to the base application after it hits all the middlewares. And then when the base application wants to send a message, like send a packet, it first goes to the base application, does its logic, and then sends it out to core IBC. But instead of sending to core IBC, the middleware is in the middle, so it catches it, does some logic, sends it to the next middleware, it does some logic, and finally it gets to the core IBC. So you can look at it as if like there were two stacks, right? So one stack for going down and one stack for going up, right? Okay. So this is the overview of a middleware architecture. Even though like we will see how to form these stacks, but we won't really see how to write the middleware itself. Instead, in this workshop, we'll just look at how do we wire it up. So we will have a base application and we'll actually wrap it in an existing middleware rather than creating the middleware ourselves. Are there any questions up to here? Okay, doesn't seem like it.
Yeah, they're on board. No questions for now.
Okay, so this is the workshop. So this is the presentation. So let's actually start the workshop. Okay, so I hope those of you who want to follow it live already install the dependencies. So you start here, right? You go here, and then after I have all these dependencies already, so I can go to the next step. So the first thing we'll do, I've created this new directory in my machine called workshop, and it has nothing in it right now. And we'll create a chain from scratch. For this, I decided to use Ignite. So Ignite is basically, if you worked with the developer portal in Cosmos Network website, you already know what Ignite is, but it essentially does certain things for you. It can create a scaffold, a chain. It can scaffold a custom module. This is what we will use for our workshop. The first command basically just creates a chain, and it creates it with no custom modules. So basically, all we'll get is a chain that runs. So let's just do that. Let's actually run this command. So it might take some time. Also, please let me know if the screen is not large enough or it's hard to read, so I can zoom in more. Okay, so the chain is created. So I call this chain foo. So we can go to the foo directory now. So you can see that there's only one directory now. And if you look at the files, it created some files. Okay, so let's see if this chain runs. So we just formed the chain. Let's see if, like, without doing anything, we can run this chain. So we just run this command, which is to basically serve the chain. Again, this is also going to take some time, but it's good to do it at the start. So if it needs to install any dependencies, it's just installing everything right now. Make sure that there is no issue, just compiling the code, and then we can start modifying it. Again, this might take some time. Okay, so the blockchain is running right now. So it's that easy to just create a blockchain that runs on your machine. You can see that it also created some wallet addresses. It's also telling you where the endpoints are and binaries. Okay, so now we can stop the chain. Okay, it's running. So what I want to do is now I want to update the Cosmos SDK version and IBC Go version, because at the time I wrote this tutorial, these were the latest. So this command just bumps the SDK version. So let's just do that. So yeah, we just bumped the SDK version from 47.3 to 47.5. And let's bump the IBC Go version as well. This was 7.1, I believe, in this like chain that we created. So let's just update it. Sorry, I think I lost my sound there for a second. But so now that we updated IBC Go and Cosmos SDK, let's just see that it runs. It runs even after we do this. So as you can see, it's already saying that the SDK version has increased. Before it was 47.3, now it's 47.5. Yeah, the chain is still running. Everything is good. We can stop it now. Okay, so this was the first part. So just have a chain running, and we just did that. Next step. Okay, so now we actually want to wire up the fee middleware to a Cosmos SDK chain. Now the fee middleware. So there's two concepts here. One of them is a being a Cosmos SDK module, and the other one's being an IBC middleware. Technically, these two things can be separated. So you could build a Cosmos SDK. So you could build an IBC middleware that's not a Cosmos SDK blockchain. So that's not a Cosmos SDK module. What that means is, for example, the middleware wouldn't have its own state. So it would just be a stateless middleware, just doing some static checks. And we have such a middleware in IBC Go. So there are reasons to think about these. But in this case, the fee middleware is both a Cosmos SDK module and the IBC middleware. That's basically fitting on the stack that we were talking about earlier in the presentation. So what we are going to do is we are going to open up the code and we are going to actually wire it up. So let's do that. So let's use your editor of choice. In this case, I'm using NeoVim, and you can see the file tree is here. So let's just maybe start with app.go. So this is where the actual wiring of all the modules happens. So this is the file that basically like initializes all the modules, initializes the Cosmos application. Okay, so when we are here, I just want to import these three files. So let's just import these. So probably go somewhere like here, right? So yeah, let's just add it here. And yeah, why not? Let's fix these. Okay. So we just imported these. It's giving an error because what it's saying is that, okay, you've imported these, but you're not using it at all. And we will use them in a bit. The next thing it wants you to do is basically add the fee middleware to the module managers. So it starts with the basic manager. So let's just go there and add the fee middleware to the basic manager. Yeah, new basic manager is here. And here, as you can see, I added it right under vesting. So let's go to vesting. Vesting is right here. So if you go down and we can, basically we can just add something here. And what we want to add is this. So essentially we are wiring it up as a Cosmos SDK module now. This is the basic module manager and we are adding it. I'm using a weird keyboard. Okay, so we've added it. We can just save this as well. And also it's also saying that we also want to register the module account permissions. In this case, it's nil. It doesn't need anything, but we should also add this. So let's just do that. Okay. So it's added here. Next, we are going to add it to the actual module manager. So this is not the basic manager. This is the actual module manager. So let's find it. New manager. It's here, right? Yeah. And we are going to add it right under SCA module. So right here. Right. And the thing we want to add is this. Okay. So it's warning me that the IBC app.ibc fee keeper is not defined because we haven't defined it yet. It's a later step that we'll define it, but we are gonna have that, and we'll come to it. Like I'll explain what a keeper is when we are doing that. Okay, so next step is to create the keeper that it says is undefined. So let's just go to the abstract. Okay. And so here are all the keepers. Basically, a keeper is what keeps the state of certain application. So it's basically used for state management. If your app doesn't have a state, it doesn't need a keeper. But in this case, the fee middleware has a state. And why does it need a state? Because it's going to store and manage all the fees that the user is going to send to it. So it's going to have to keep the funds, and it's going to have to pay the fee to the relayers. So let's just add this in. I added it right under IBC keeper, right? Okay. Yeah. Okay, so IBC fee keeper is the thing we imported at the start, so this should be fine. As you can see, there are no errors anymore. The IBC fee keeper is now exists, but we haven't initialized it yet, but it's now defined. So, and to manage your own state, you also need to register the storage keys. So we will do that. So let's just go there. OKV store keys. And then we are gonna add this to it. Yeah. We've added it. So next, finally, the thing is, so now we have registered the storage keys. We have added it as a field to the application that it should know about the IBC fee keeper. And now we actually have to initialize it. It says here, it should be, the initialization should happen before transfer keeper and after IBC keeper. And why is that? Well, it's using the IBC keeper. So, okay, it should be initialized after the IBC keeper. And why does it need to be initialized before transfer keeper? Is because when we are building this middleware stack that I mentioned, IBC keeper is going to use the fee keeper. So that means the fee keeper should be initialized before. So yeah, so let's do this. Yeah, so let's find IBC keeper. Next, this one. Okay, so this is where the IBC keeper is initialized, and this is where the transfer keeper is initialized, and we want it to be in between the two. So here seems like a good place to inject it. And we need the tab, so let's just do that. This is weird. Okay, like this. Tab. And then I'll do that. Okay, just do it like this. Okay. So the fee keeper that we just added as a field to the application is now initialized. Yeah. And now, because it's a SDK module, we need to add it to set order begin blockers and set order end blockers. To be honest, I'm not sure if we actually need it, but it's the way the example was done. So I'm gonna do this as I did this in my tutorial as well, because I don't know if you're actually using the begin blockers and end blockers, but yeah, let's just do it. And then where is it? ICA types. Okay, there. So we add it here. We add this. Okay. Next, we do the same thing, which is in the order end blockers. Again, adding it right after ICA types. Same thing. Okay, so we added it into end blockers as well. So next, and we also need to add it to Genesis module order. So this basically defines in what order the module should be, I guess, go to Genesis. So it's right here, and it's right under ICA types again. Right, so the reason why we can only just insert these constants, which are the module names, it's just phi IBC in this case, it's just a string, is because when we register these modules to the module manager knows their name, so it will know, it has a map in that says which module name corresponds to which module actually. Yeah, so that's part of the reason why we have to register these to the module manager. Okay, oh, did I scroll too much? Okay, so we have done this now. And next is we are going to go to the so we have wired it up as an SDK module, but we haven't really touched the IBC stack yet. So far I've never really touched anything related to IBC. So now we're actually gonna do it. Okay, before we maybe move on to this, I will take some questions before I actually start wiring up the fee middleware as an IBC middleware. So let's see if there are any questions. Yeah, it doesn't seem like there are any questions, so maybe we can proceed. Right, so let's go to the transfer keeper. So this is the first step. So we are replacing the channel keeper with the fee keeper. So let's go there. Let's find the one. Okay, here. So this is where the transfer keeper is initialized. You can see that it takes the channel keeper 2 times, and we'll get to why. Okay, so we are going to replace that with the fee keeper. Now, why can we do that? So the ICS 29 fee middle. So as I said here, I'm just going to read here. So the idea is that the ICS, so the fee middleware keeper implements the ICS4 wrapper interface. And what that means is basically the IBC fee keeper wraps the channel keeper. So IBC fee keeper does actually have the channel keeper inside it. And also it means that it can replace the use of the channel keeper for sending packets, writing acknowledgements, and retrieving IBC channel version. So what that means is we can actually replace the channel keeper with the IBC fee keeper for these use cases. But you'll notice that there's still another channel keeper that we didn't replace, and that's because there are other use cases of the channel keeper that ICS4 wrapper interface cannot replace. So for those use cases, we need to leave the channel keeper, but for the use cases we need, which is the middleware interface, yeah, for the use cases we need, we are going to replace it with the fee keeper. This ICS4 wrapper interface is not a mystery. It's a part of the middleware interface. The middleware interface consists of 2 interfaces. One of them is the ICS4 wrapper. So now we are using the fact that middlewares implement ICS4 wrapper to replace the channel keeper. Yeah. So let's do that. So let's just insert it here. App dot. We're just gonna do IBC fee keeper, right? Yeah, that's right. And then we're going to delete the other one. Okay. So that's fine. And the next thing is we are going to actually create the IBC stack, because so far I've only talked about I haven't really created the middleware stack that I was talking to you about, like where you wrap the thing. So now we're actually going to wrap the transfer module inside another module, which is our middleware. So to do that, we're going to go to where transfer IBC module is defined. So let's find it. Okay, so it's defined here. So you can see that the transfer module is a SDK module, and the other one is the transfer IBC module is an IBC application. So we don't really care about the SDK module one because it doesn't receive the IBC messages. The one that receives IBC messages is the IBC base application, which is this transfer module. So what we need to do is we are gonna need to wrap this inside the middleware. So let's do that. So yeah, right. So what we are gonna do is we are gonna remove this application. We are gonna remove this app, and we are gonna instead create a stack. So let's do that. So maybe I'll take these 2 and start. I'll delete it at the end just so I can explain what's happening. So let's delete this plus at the start. Do this. Okay, so we've defined something. We call transfer stack, and basically we are just saying that it's an IBC module, and transfer IBC module itself is an IBC module. So the transfer stack is going to replace the IBC module usage. So we are going to remove this and just use the transfer stack after this. Before it was just a module, now it's going to become a stack. And the first element in the stack, the base app, is the transfer module. So we're actually going to basically copy this line here, and instead of saying that it's a new module, it's a part of the transfer stack. So we are going to initialize our transfer stack as the IBC module, right? So that's what we should be doing here, and that's right. And the next thing is we are going to redefine the transfer stack. We're going to redefine the transfer stack, and basically we are going to create a new middleware, and it's going to wrap the transfer stack and also have the fee keeper. So yeah, so basically we'll create a new middleware that wraps the previous application, and now we don't need this anymore. Okay, so this transfer stack is what we will use rather than the IBC transfer application. Now you can see that we have an error, and you can see the error is that somewhere we are using transfer IBC module. So if we go there, it now says that, okay, if we have an IBC router and the IBC router says, I don't know how to route these things, the messages that are coming to the transfer types to transfer IBC module because that's not defined. So we are going to tell it to route it to transfer stack instead. And transfer stack can go in here because it's an IBC module. Yeah. So if you go to definition, you can see that we defined as a IBC module, so it will be able to go there. And yeah. And close this now. Yeah, and that was the next step. So we've done this, and it should work. So we've basically wired up the fee middleware on a chain, and I don't think there's any other steps we need to do. So let's just go out and see that the chain is running, and to see that we just run this command. So everything looks great. The blockchain is running. And yeah, we can stop the blockchain now. And yeah, this completes the wiring of the middleware stack. So the next parts are about actually, so this is all the blockchain part. The next part is about, creating a React application and actually wiring up this to the React application. But I've been going faster than I anticipated, and in my other workshop. So I think this is also a good place to take a break as well and answer some questions. So I don't see any questions so far, and I'm gonna take a break. So about 10 minutes. When we come back from the break, if there are any questions, I'll take them. In the meantime, if you want to set up these test wallets, like if you have been following and you want to set up test wallets and be able to follow the workshop, continue to follow the workshop, you can follow these steps as well. Yeah, actually, yeah. So basically, what you have to do to continue following the workshop is during this break, you just take these 4 mnemonics and add them to your Kepler, so you can use them. You could probably generate your own mnemonics and just save them, but this is just easier. So that's it. Okay, I'll take a 10-minute break. Is that good?
Perfect. Yeah. Yeah,
Great.
guys. So we'll see you after 10 minutes. Meanwhile, you can just take a recap on what Serdar just mentioned. See you in 10.
See you in 10.
Back.
Yeah, so I'm gonna end the break soon. Were there any questions during the break?
No questions for now. I think all is well.
Great, thank you. So I guess we can get started with the workshop again, and I'll share my screen again. Oh, okay. I'll share my screen again. Also, can you mute if you are not? Thank you so much. Yeah. Okay. Let's go to where we were left, which is the scaffolding in the React application. So the first part of the workshop was about getting the chain to work with the IBC fee middleware, which we have. The second part of the workshop is about getting a front end to wire it up and then actually seeing it in the function. Yeah. So so I was talking about setting up these 4 test wallets, which I have done already. You can see that they are here, the 4 test wallets. And I want
So
to
cannot see your screen. Maybe if you can, just
is it not
share
sharing?
again. No, I cannot see it.
Oh, interesting. Oh, now is it
Yes,
sharing?
yes, yes. Now it is perfect.
Okay, sorry about that. So yeah, let's do that again. So what I was saying is, yeah, so where we were left off was scaffolding the React application, right? So the first part of the workshop was about setting up the blockchain to work, which we have done. The second part of the workshop is about getting a front-end application to work with the fee middleware. And the first part of that was setting up these test vaults in your Kepler. So as you can see here, I have set these 4 wallets up, which are corresponding to the names here. And the next thing is we want to fund these wallets in the chain. So I'm just adding it with the mnemonic. These wallet addresses to the config file. So let's just do that. Yeah, go back to my editor, and let's just go to config and add these here. Oh, but sorry, let's just add this here. Great. And yeah, so now we can get to scaffolding React application. If you run this, you'll see that these vaults are funded now. So let me just quickly show that to you. Yeah, so as you can see, the wallet addresses have been funded here. So these 4 wallets. Let's stop that again. So right now we don't have anything related to React. So we are going to have to scaffold it using Ignite as well. So this command ignite scaffold React will actually do that. Okay, it's already done. So it has just scaffolded the React app in the React directory. So if you list the directories, you can see that React is there. And the next thing is we are going to clear the cache. Sorry, we are going to generate hooks. So Ignite is just a front-end application, but it doesn't have any TypeScript. The TypeScript client isn't there. So generating hooks basically generates the TypeScript client and the React hooks for that client. The reason why we have to put clear cache here is that we've added a custom module to our chain, which is fee middleware, and the current cache doesn't know about that. So by clearing cache, it basically makes it query all the modules again and see that the fee middleware is there. So yeah, because I have been committing my changes to Git throughout this workshop, we can proceed without doing this. So it's generating the TypeScript types based on the protobuf definitions. Might take some time. Okay, so the TypeScript client and the React hooks have been generated. Yeah, great. So yeah, so what we can do now is so because we are using a later version of the Cosmos SDK, some of these dependencies that the TypeScript client and the React are using are not up to date. So we are going to update them in a similar way that we updated the Cosmos dependencies, right? So we're just going to run these commands. So this one is for updating the TypeScript client. Oh, I remember you remember this issue. I think the copy button wasn't working for some reason. Let's just do this. So yeah, we first went into the TypeScript client and then installing all the npm dependencies with the correct versions we want. And again, this is taking some time. I think it's because none of the npm dependencies were installed. So now it's actually installing them as well. So let's get out of this directory and do that same thing for React dependencies as well. Okay, so the React dependencies have been updated too. Now there's a bug in the generated app that we need to fix. So this is something that was a problem with the Ignite at the time I wrote this, and this was the latest version of Ignite at the time. But the problem was that inside this specific directory, like this index.ts in one of the hooks, they generated code that has a string equals star star in certain places, and it just shouldn't be there. So it's not that you need to change something, but it's just that it's not supposed to be there. So we can remove this using replace. We can use this following command that just removes that character from this file. Or you can go there with your editor and like remove them manually. I'll use this sed command and do it. Okay. Oh, sorry, this is supposed to be run on the root of the project. Now it's done. Okay, so now let's just see if the app is running or not. So both the front end app and this, right? So what I'm gonna do is I'm gonna start off by splitting my screen. So let's just run the blockchain first, which is gonna be oh yeah. Luckily, I can just say no. Sorry, yeah, we didn't mean to run that command. Yeah, this one. Okay, so now we are running the chain. Next is we are going to run the front end and see that it's running. So go to React and see that it's just working. And the command we need to run here is npm run dev, right? Yeah, npm run dev. Okay, so all we need to do is go to this address. I don't want to go to my default browser, so I'll instead go here. Yeah, okay, now we can connect our wallet. And yeah, we can see the balances of Anna, which is there's two types of tokens, stake and token. Everything is working. The front end is there. You can send and receive tokens. If you press advanced, you can do an IBC transfer by filling in the channel. If you don't fill in the channel, then it's not an IBC transfer. If you fill in the channel part, it's an IBC transfer. If you fill in the fees, it's just normal Cosmos SDK fees. This is not the relayer fees. So now our goal in the workshop is to add a relayer fees field to this front end. So we're actually going to modify the front end and make sure our middleware works with the front end and then actually demo it. So now we can basically stop all these processes. So let's stop the front end and then stop the chain and start our modifications. Yeah, and we've seen it work. So let's go to the next step. Now, the next step is that we are going to go to the state of this React app and add the relayer fee as a state. So people can store their relayer fee before they press send button, right? So this is an ignite send.tsx. So let's just go there. And yeah, we don't need this anymore. So ignite send, so it's here, and the tx data is here, and we just need to add a new field to it that says layer fees. Great. So that was the first thing. The second thing is we're going to need to initialize in the initial state. We want to have something for it, so we're just going to set it to the empty array. So initial state. Oh, it's in a. Okay, I misspelled it. And it's right here. Yeah. Okay, so the initial state of that field is empty array. And the next thing to do is we are going to basically add a new function that updates the state. This function will later be called from the front end, but the first step is to have the function that can update the state, and then we'll integrate it to the front end later. So let's just take this function and add it right after handle txfees update. So let's just go there. Yeah, it's here. So here, so we can just add it to here. Yeah, so this is where we added it, right? Okay. These pluses are not good, so let's just remove them. Okay. And we can fix this. Right, and then this. Great, so the only problem is that the function is not called. If I want to, I can also say ESLint fix all, so that it's like it does it for me. But okay, everything seems good. Next thing is we're gonna actually add the front end item to the actual front end. So let's do that. This is supposed to be at the end of ignite send. So Yeah, let's go there. Where was that? Set state. Next, it's here, right? Here, yeah, this is right here, and we have put it this under input wrapper. So if this is input wrapper, this is it. We need to put it under here. Again, let's just get rid of these. And this, oh, what did I do? Take that back. This. Let's see if ESLint can fix that. Okay, it can fix it. Great. Okay. So now basically we've added the new new part to the front end that basically says relayer fees, and then it has this component from Ignite which is called amount select. It's a token selector, and it's basically is for the state relayer fee. And the way it's updating it is by calling the function we've defined earlier. And yeah. Okay. So at this point, we should probably run the application and see that it still works and we haven't broken something. So let's just do that. Again, it's probably a good idea to split the screen right from the chain. Okay, and let's also run the front end, npm run dev. Okay, everything should be running now. And let's go to our page. Okay, and connect our wallet. And as you can see, we have the field added here. Right now, we've just added the field. The field doesn't do anything. So all it does is just storing the fees in the state of the React application. When we are sending the transaction, we are not using these fees yet. So the next step is to actually do that. Yeah, the third step is add the transactions to the fee, to add the fees to the transaction. Okay, so let's go back and do these apps. Actually do this. So first we need to find out where the transaction is constructed. It's in the same file. So we go to send again, and where it's constructed is yeah, the function is called ignite send again, which is here. Yeah, so the transaction is created here. Before maybe I start this, I want to see if there are any questions. Which see, okay. So there are no questions. Yeah, so before that, the only messages we were sending were, send and message transfer. Now we are gonna we are gonna have a new message type, which is the pay packet fee, which we are gonna bundle with the message transfer. So we are gonna add these two new things to our transaction constructor, which is happening inside Ignite Send. So let's just do that. So right under here, I think, right? Again, we don't need these pluses. Okay, so it's saying, okay, these are never used, which is right. And the next thing is, okay, so you can see that, yeah, you can see that they're defining all the amounts they're going to use here. So first, this is the Cosmos SDK fee. The next one is the amounts that are going to be sent. And the third one should be the relayer fees. So let's actually construct them here as well from the state, because the thing in the state might not necessarily correspond to the relayer fees. And in fact, we might also want to do some transformation on them. Like, so this is what the user selects, and we need to do some transformation. And in this case, we are actually going to do a transformation. So before maybe I start adding this, we can look at what the function is doing. So, yeah, what the function is doing. So what the function is doing is basically, essentially what we are doing is we are going to, we are going to divide the amounts that we are going to send by 2, and I will come to why we are doing this. But I think it's important remembering how the IBC packet lifecycle works again. So maybe I'll take us back to here to explain why we are dividing it by 2. Okay. So in the good case, you can see what's happening is the relayer is actually sending 2 messages: packet, message receive packet, and message acknowledgement. So what that means is when the user selects something in the UI that's basically saying, okay, I'm gonna pay, let's say, 10 atom as my fee. Obviously, it wouldn't be that high, but I'm giving an example: 10 atom as my fee, or 10 stake as my fee. They don't want to pay 10 atom for both of these messages. They want to pay probably 5 atom for the first one and 5 atom for the second one. So that's why basically when these two are basically taking separate fee structures. Yeah, so that's the reason why we are going to divide them by 2, because what we are going to do is we are going to pass the same amount to each, right? So we are going to pass 5 to this and 5 to this. So okay, so that's the reason why we are dividing the relayer fee by 2. And another thing is, okay, I should have shown it here, but you can add multiple assets as relayer fees. So what that means is you can pay 10 atom and also 6 token, and then the first relayer would get 5 atom and then 3 token, and the other one would also get 5 atom and 3 token. So you can add multiple. So this is why this is an array, and you can add multiple assets under it, so not just one. Right. So this is why we are doing this transformation where we are mapping each amount to a different amount, which is a new amount, is where it's divided by 2, and the denomination remains the same, but we are using the new amount instead. And the reason why I need to do this parse int like weirdness here is because the prototypes expect these fields as strings, but they're actually like numbers. So what I need to do is I'm going to parse it from a string back to a number, divide it by 2, and then parse it back to a string. So that's why this logic is a little bit more complicated. It looks a little bit more complicated than it actually is. Yeah, and that's why this weirdness is also happening here. So it's saying if it's the empty string, replace it with 0. Like, yeah, so we don't pass in something that's like malformed to the chain. Okay, so let's just do this. And one more thing, you might ask what happens in this case where like there are no 2 messages, there's only 1 message. Does this 1 message take 10 atom in that case? And that's not what's going to happen. What's going to happen is it's also going to take 5 atom, and then the other 5 atom is going to be refunded back to the user once this relaying happens. So you're actually just whatever you're sending is going to get divided by 2. Yeah. And then if there's only 1 relaying message, then you get your feedback. Okay, but that's just how the middleware works. That's not some logic we are going to build in the front end. Okay, we can get rid of these pluses again. Okay, let's run yes, then fix all. Good. So now we've defined the relayer fees, but it says, okay, relayer fee is declared, but it's never used. And now we're actually going to pass it to the message that we are sending to the chain. Like this. So we are going to replace the original logic. Let's just find where it was. Okay, so first of all, yeah, you can see that there's this thing is defined. So there's the memo. It's saying, is this an IBC transaction? Which is the way it's checking that is by checking whether the channel field on the front end, which is this field, is empty. It says if it's empty, then it's not an IBC transfer, but a normal send. If it's not empty, then it's doing a normal transfer. So what we are going to do is we are going to define a new thing, because it. Oh, I know what I did. Okay, I think I know what I did, but anyway, let's go back to. Oh yeah, we are gonna add another thing here called isFee. And the way we can check that is checking by whether or not the state's relayer fee length is greater than 0, right? So if the user has set up some relayer fees, then we are going to say this is a fee transaction. Okay, so how are we gonna handle this now? So here is the logic for actually doing the sending the message to the chain. So if it's IBC, it's doing something, and if it's not IBC, then it's just doing the send message function, which is from the TypeScript client. And notice that we also imported some stuff from the TypeScript client, which are these message pay packet fee. So if you go to here to see what it is, you can see that it's basically constructing a proto message. And if you look at the if you look at what the field it's expecting, okay, it's expecting a fee field, it's expecting these things. I just want to show you this so you can know what we're talking about, but it's not necessary to know this. So let's just go back to where I was. Okay. So all I'm trying to say is we also imported these messages that we need to use. And what's happening here is if it's IBC, it's doing something. If it's not, it's sending just a normal send message. If it's IBC, then it's defining a new payload. So it's taking the previous payload but adding the source port, source channel, blah, 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 and then doing a send. We're going to modify this logic. So what we are going to do is inside is IBC. We're going to remove the send, and we are going to add our custom logic, which is checking if it's fee, it's doing something, and if it's not fee, it's doing what it was doing right here, right? So let's just first delete this. So next we are going to actually add this logic, which is if it's fee, do something, if it's not, do what you were doing before. So let's just add it here. Okay, maybe I can add it like this. Seems like better. Good. And these pluses are causing all these issues, so let's just get rid of them. Delete. And then complaining, so let's just run an ESLint. Okay, not complaining anymore. So as you can see, what's happening here is if it's fee, it's gonna do something. If it's not, it's doing what it was doing before. But if it's fee, what it's doing is it's creating a pay fee message, which is basically telling it the signer and the fee. The fee consists of these three fee fields, so receive packets, receive fee, acknowledgement fee, and timeout fee. And we are putting the same thing to all three, which is if you were paying 10 atom as fee, then these are each like representing 5 atom, for example. And the idea is that you can only ever get two of these, right? So the idea is that you're either gonna do receive and acknowledgement, in which case you're paying 10 atom, or you're just gonna do timeout, in which case you're paying 10 atom. But you're never paying all three, actually. Yes. Okay, so this is it. I think that we just added the final logic. So, okay, we create this message, and then we also create a message transfer message, right? And we need to combine them into the same transaction. So you can see that there's a sign and broadcast function. And basically what we are doing here is putting the two messages back to back. So pay fee message first and then transfer message. And the trick here is to put them back to back. So the way this workflow works is you're paying the fee, and then the first transfer that happens after the fee is like where your basically fee is going to. But let's say this is important to add them into the same transaction rather than sending two separate messages to the chain. Because in that case, if you send the pay fee message first and then send another message, someone else can front run you and put their transfer message in front of yours, and then that's going to be a problem, and because you're going to start paying fee for them. So we're actually using the fact that Cosmos has atomic transactions, right? So by putting these into the same transaction, we are making sure nobody can insert something in the middle. But you might ask, okay, but what if I didn't provide enough fee when I paid for it for the first time? So I'm trying to send the transfer message. I paid some fee, but it was too low, and now no relayer is relaying it. How do I increase the fee? There's a separate message for that. It's not a part of the workshop, and you're welcome to research it on your own. Here we are just adding this workflow for fee payments, and there's actually another workflow where it's called async fee payment, where you've already sent a packet, and then you can start adding fees to it out later in order to incentivize people to relay that packet later on. But we are looking at the workflow where you are paying the fee from the get-go. Yeah. Okay. So I hope this explains everything that's happening here. So now we can actually run a demo. So we can actually run two chains, use the front end, and send the fee transfer. Yeah. So let's do that. Next step. Okay, so now we want to run two chains locally. The idea is that one of them will be called Earth and the other one will be called Mars. And for that, we are going to add new config files because currently in Ignite in our Ignite file, there was only one config, right? So now what we are going to have is we are going to have two configs. One of them is called Earth YML and the other one's going to be called Mars YML. For some reason, this copy button wasn't working, so I'm just going to go see the full example in GitHub and then just copy it from there. So let's copy it and let's create it, right? Yeah, Earth YML. Okay. So let's create a file called earth.yml, and also let's do that for Mars. Let's go to Earth first. Oh, I created these in React. Oh, no. So let's just move these. So yeah, so let's just move it like this. Let's do that for Mars as well. And should be here. Yeah, they are here. So let's do that. Okay, so let's start with Earth. Let's paste what we have. And you might say, okay, what's the difference from config YML? Actually, this one I don't think has any difference from config YML. I think it's pretty much the same thing, except the chain ID is defined as Earth. So that's good. So it's exactly the same. Oh, why did I quit? We actually want to go to Mars as well. So let's go to Mars and fill it as well. And the Mars is actually here. We can also see it in GitHub if I click this link and copy the file and paste it. This one does have some difference. Other than chain ID being Mars, it also defines a new port for each of these gRPCs, peer-to-peers, RPCs, and API. And the reason why we are doing that is because we can't have conflicting forks, conflicting ports, because what we're going to do is we're going to run two chains on the same machine. So if they have if they map to the same ports, then they won't be able to start. The ports shouldn't be already taken. So basically, what we've done is we basically defined different ports. Yeah. So now we've added everything, right? So let's see. Yeah. So now we're gonna actually run the two chains. Okay. So this is just testing whether the two chains work or not. So let's just test it. And here you can see that we are using the dash like config argument. Let's run the Earth here, and let's run Mars here. Okay, so now we are running two chains on our machine. You can see that the API ports are different. They're not mapping on top of each other. And everything is good. So we've seen that both chains work. There's nothing wrong with the configs. We can stop these chains now. And you might ask, okay, why have I been passing this reset once? So I'm just resetting the whole chain. So I'm not using the genesis. So I'm not using the state that was saved from the previous run. So that's the reason. Okay. Another thing we need to do is we're gonna need to run a relayer. And I chose Hermes for this. You can use both Go Relayer and Hermes. They are both fine in production. I chose Hermes in this example. And here's the example config file that we will use. So there are some important things here which we'll go through. But first, let's just add this to our project. So I'm just gonna copy this as well, just like I did with the other config. So I'm gonna go see the full example in GitHub. I'm gonna take this config file, and I'm gonna explain more about that in a bit. And yeah, so let's create the new. I just want to make a new directory first. I'm just gonna call it Hermes, so we can put everything related to Hermes in there, right? So I'm gonna maybe create a new file there inside Hermes called config. Yeah, config.toml. And then let's go in there. And then let's paste what we have. Oops. I copied the link. I don't know how I did that. Yeah, I copied the link. Okay. Let's copy the file. Okay. Yeah. So let's just save this. Let's go to the start. Okay. So I want to show some of the important things that we did in this config file. for the Hermes relayer. So one thing is the register counterparty payee. So that's actually important for the fee middleware. And you might ask, okay, what is that? So as I said, there are basically two relayers when you are relaying, right? So the one relayer is basically submitting messages to chain A, and the other relayer is submitting messages to chain B. They might be running on the same machine, or they might be running on they might be running in the same relayer software. So the same relayer software manages two wallets, which is what might be happening. Or they might actually, two different people, two different machines, and one of them happens to submit the receive part and the other one happens to submit the acknowledgement part. But the idea is that these are different wallet addresses. But as I said, all the fees must be paid in chain A, because that's where we locked the fees. So what that means is, for the chain B relayer, so whichever wallet submitted this packet to chain B, needs to have another address in chain A to receive these fees, and they must register that by submitting basically a message called message set counterparty payee or something like that. And when you set auto register counterparty payee to true, because the relayer already has two wallets, one of them living on chain A and the other one living on chain B, it automatically does this register when it's setting up the relayer. So by setting this to be true, we don't need to do any additional things. It just automatically does this process for you. Okay, and the other thing is, just if you've never run with the relayer, I'll quickly show you. So this is where the chains are defined. The first chain is Earth. This is the chain ID, and then here are their endpoints. These are the important things, and the endpoint for the WebSocket is this. So these are, when you're relaying, these are generally the only things you need to change: the ID, these things, like to make sure the ports and the links are correct. And same goes for Mars. Yeah. You might notice that I have these wallet addresses called key name Damien, because, as I said, if this is a chain, there needs to be a wallet that the relayer has in order to submit messages. Here for Mars chain, I have a wallet called Damien, and for Earth, I have a key name. Should be Charlie. I can't find it. Charlie. Okay, yeah, key name Charlie. Okay, but I haven't registered them yet. So actually, the relayer currently doesn't know what Charlie or what Damien is. Now, okay, so next thing is we are gonna actually put this Hermes config to the expected directory. The expected directory is in your home folder, .hermes and config.toml. Right now, I just put it in my project, so we need to move it there. It is possible to work without moving it there, because the Hermes has a command for specifying where the config file you want to use is. Just for simplicity, I'm going to move it there. And actually, I might have other things set up there. So to make this workshop more accurate, I'm just going to, first of all, remove that entire directory, right? So the home folder, and then we need to do .hermes. So I just removed the entire Hermes folder. So now I have nothing in there. Let's just create it again. Now we have an empty folder there. And now I'm going to move this copy my config to there. Okay. It should be there now. And we're also going to, as I said, we need to have two wallets, Charlie and Damien. I'm just going to put their mnemonics in a file so Hermes can use them. Again, I'm going to put this in our project. I'm going to create these things. So let's say inside Hermes, I want to create charlie.mnemonic and also create Hermes Damien. Hope I spelled those correctly. Charlie mnemonic. Let's just add it in there. Save it. Oops. Save it. And then let's do that for Damien. These are the same mnemonics that I used in my they're the same mnemonics that I've used in my wallets for here. You can see I already registered these in my wallet. These are called Charlie and Damien. Okay. So next thing is, as I said, even though we have these mnemonics in a file, the relayer doesn't know about them. So we can add keys to the relayer. It's called Hermes keys add, and we are gonna tell them the key name is Charlie, so that remember in the config file I showed you that the key name was Charlie. And then which chain it's for, so it's for the Earth chain. And where is the mnemonic? So I'm using a mnemonic file to register the keys, and it's right here. So let's just do that. Let's just run this command. Also, you can see that I'm using the correct version of Hermes, actually. Am I? Yeah, I am. Okay. Yeah, you can see that it says, okay, successfully restored key. And let's do that for Damien as well. Okay. Now, we have everything ready. So we have registered the keys. Both chains were running. We tested it. The front end was running. So now all it remains is to show that they can all run in a demo. So let's just do that. Let's clear here and prepare for a demo. For this, I'm going to need 4 terminals, because 2 of them are going to run the chain. One of them is going to run the relayer, and the other one's going to run the front end, right? So let's run the chain first. Okay, let's run the second chain. Great. Let's run the front end. Okay, it's running. And finally, let's run the relayer. Oh, okay. Before we run the relayer, we want to create a channel between the 2 chains. So we have the channel, we have the 2 chains now, but if we run the relayer right now, it's not gonna be relaying anything because we haven't created an IBC channel between the 2 things. So we basically need to do the channel handshake. So this is the command for actually doing the channel handshake. Usually, when you create a channel, of course, there has to be an IBC light client underlying the channel, and then IBC connection that's connecting those light clients in those 2 chains. Here, this command adds the command at the end that says new client connection. Basically, it's just saying that, okay, while you're creating this channel, just create a new client and connection so that we don't need to deal with that. And so I just want to go over what this command is doing. So we are setting a channel version. Before that, we are creating a channel between 2 chains, the Earth and the Mars. And the reason why it knows these names is because we've registered them in Hermes' config. And the second thing is the ports of them is transfer. So just use the port transfer on both of them. So why are we using port transfer? It's because when we added the IBC router, remember, the actual name of the thing was, the actual name of the module was transfer. So if you want to actually see that, we can go there. I can just show you this very quickly. App.go. And where was it? Transfer stack. Next. Okay, here. And so the router is basically taking this module name, which is transfer. So that's why the port name is transfer, because in the router it was registered as that. Okay, so it's connecting two transfers. We added the fee middleware there, but if the channel version doesn't tell it that it should use the fee middleware, then it will not use the fee middleware. If you try to create it with a blank channel version, I believe it will use the fee middleware currently. But if you just want to make sure you just set the channel version yourself, we are using this specific fee version and this specific app version. These are something defined in the modules themselves, right? So we are using this JSON object that says the fee version is this and the app version is this. So let's just use this command now and create the channel. So let's go back. This was for the relayer. So let's just run the command here. So it's gonna create a channel between the two things. It might take some time. So first it created the light client. You can see it's saying that created a client. It says client was created successfully, and this is a Tendermint light client. Now this is trying to do the connection handshake. You can see this is at the first step was open init connection. The next step is open try connection, and finally it's open acknowledgement connection. So it's initiating it, and then in the other chain we are getting the try step, and then the first chain we are getting the acknowledgement step, and then it's confirmed. Okay, and now it's basically stopped, finished running, and it created the channels. And you can see that on the B side, which is the chain B side, we have the light client as the first light client, which is Tendermint 0. The connection is the first connection, which is connection 0. The port ID is transfer. The channel ID is the first channel, which is channel 0. And the version is just exactly the version we set. The same for the A side. A side will not be any different because also it's first connection. So it's the first light client, which is Tendermint 0, first connection 0, and channel 0. And the version is exactly the same. And the versions will always be exactly the same, but the channel names and the connection names may differ, or like the client names, because maybe this chain has already connected to 5 chains, whereas the other chains, this is the first connection. Okay, so we have created the channel, but right now there's no relaying process happening between them. So let's actually run the relayer by saying Hermes start. Now I'm hoping at some point in there, it has actually done the counterparty payee register, because actually this is the first time I'm trying it with that config option on and not doing it manually myself. So hopefully everything will work out. So right now the relayer is working and everything is working. So now we're actually ready to run the demo. Let's go back to our front end. We connect our wallet. In this case, it should be Anna, let's say. So you can see that Anna has 200 million stake and 20,000 token. So the relayers are here again. Remember, the front relayer is Charlie and Damien. So the relayers that are submitting to chain A is Charlie, and the relayer that's submitting to chain B is Damien. So what we expect to see is when we are paying the payment, all the fees are going to go to Charlie, because Charlie is Damien's counterparty payee. So let's actually try it. So what we want to do is, let's say we want to send Bo some funds from Anna. So copy Bo's address. It's the same as Cosmos Hub. Copy Bo's address and send some funds from us. So you can see they all have the same initial funds, right? So if you see, Charlie has, why does Charlie have some funds spent? Because Charlie has done the counterparty registration and submitted a message for that, probably, and that cost them some fees. So that's why Charlie has spent some. Oh no, they did the channel connection and channel handshake. That's also part of it. So because of those things, they have spent some funds. Okay, so but the point is, it has 20. They all have 20,000 token initially. You can see Damien is the same, and Anna. Okay, so let's go to Anna. Okay, so Anna is gonna send Bo. So this is Bo's wallet address. Let's say Anna is gonna send Bo, I don't know, 200,000 stake. Now it's gonna be an IBC transfer, so it's gonna be, let's say, channel 0. Memo, it doesn't matter. Fees, this is just a normal fee, so you can just pay something. Let's say, I don't know, like 200 stake FS fee. And we're gonna actually add the relayer fees on top of everything. So let's say we are gonna add some token, and the token, let's say 20. So as fee, we are gonna pay the relayer 20 token. So we know that Charlie has 20,000 to begin with. So after this transaction, we would expect Charlie to get these 20 tokens. So let's see. Okay, so what's happening now is we can see that the Kepler is asking for a transaction confirmation with 2 messages. The second one is the IBC transfer, which is sending the 200,000 stake to this wallet address in channel 0. And the first one is actually the message pay packet fee. And you can see that it exactly shows how much fees are being paid. You might say, okay, wait, what's this relayers list there? It actually doesn't do anything. It was originally maybe okay. It was meant to maybe at some point in the future we'd want to restrict which relayers can receive the payments, so the user who is sending the fees can set which relayers can receive them. But it hasn't been wired up at the application. So currently, even if there's something in that array, it does not do anything. So this is irrelevant. So great. You can see exactly how much fees we are paying. We put 20 there, so it's divided by 2. It's 10, 10, 10. And now let's send it. It says transaction submitted successfully. Maybe if we can refresh here, you can see that some transactions happened. Now you can see that 20 stake was taken from Anna, so we expect to see that in Charlie. So let's go to their wallet. Okay, Charlie has received only 10. Should have received 20. Right. Let's try again. Oh, sorry. 10 was received back here. Okay, what does that mean? Why has 10 been received back here? It's because the counterparty payee registration didn't happen, right? So what happened is a full transaction happened and the counterparty payee wasn't registered. So it only took one part, but the other chain's receiver hasn't received their funds, so it was refunded back to the user, which means that the config part didn't work. So we can actually do that manually as well. So I just stopped the Hermes, so we can just do that manually. Hermes, I want the fee, maybe register counterparty payee or register payee. Maybe you should have done this manually, I think. Yeah, I think it's my bad, right? Let's say help, because I never used this feature before. Yeah. Okay, let's just add this manually. I don't think trying to find a command, maybe it will do it automatically for you, but register payee help. Yeah, it doesn't seem like it. Register maybe counterparty payee. Yeah, okay. So let's just do it manually. Right, so yeah, okay. Okay, yeah, I just need to find the command for that. It should be in the doc somewhere. Sorry about that. Anyway, are there any questions until this time, so I can just answer them if there are any? Okay. Yeah, so these are the commands. Okay. I will investigate why it didn't work, but yeah, so the problem with this command is you have to actually put the entire wallet address, and that's why I don't like it. So I was excited to add this to our config, but for some reason it seems it didn't work. So we first register the counterparty fee, and then we should also register it on the other chain. This is not necessary, but let's just do it anyway. And yeah. Cool. Let's run the relay again. Hermes start. Let's do another demo. Okay. Second try. So let's choose some amount of token. Let's say 10 maybe. Oh, sorry. Let's try to send 30 tokens. And what we expect to see is that 30 tokens will go to Charlie, in which case they should have 20,040 because they already have 10. Channel is channel 0. Again, let's just try to send 200,000 and same fees. Send. So this should decrease by 30, right? So let's just refresh it. Again, it did decrease by 30. This is correct. Let's go to Charlie. Man, you can see Charlie received 30 this time. So this is correct. So for some reason, it didn't do the counterparty registration. I'm sure I will update the document. Like I will update the workshop with whatever needs to be done to make that registration happen. But otherwise, you can use like some manual commands to register the counterparties yourself, and it should be fine. Yeah, I was already a little bit faster than I expected, so I guess with this little kink, I guess this little trouble, we are about time now. Yeah, are there any questions? This was the demo. This was the workshop. I hope you all enjoyed it and learned something. The goal was here to, you run your own chain, you run your relayers, and you also get to explore relayer incentivization and understand some of the design decisions and choices we've made in order to make that possible. And I'm happy to answer any questions.
Yeah, thanks a lot, Serdar. Looks like everyone is on board with the workshop. All good over there. But happy to give you the spot to you again, and for you to share any socials, any way of reaching you out in case anyone is facing any difficulty, problem, query in the process. How should they be reaching out to you?
Right. So we have multiple support channels on Discord, and I will maybe put some invites on the link, but I'll just say them by name first, so people can actually search them as well if they don't find some of those links. So first one is the Cosmos Discord. There's like a support tab there, developer support. So there's like a forum there with a bunch of questions. You can submit your questions there, and hopefully within a day or two, me or someone else will take a look at your IBC question and like answer it. The other one is IBC Gang. So it's another Discord channel where people can ask for support for IBC related subjects. Also quite popular. It's a little bit more technical than the other one. So for more complicated questions, certainly somewhere you can check out. Or if you're doing like, of course, every part of Cosmos Stack has its own Discord channel as well. So if you're doing IBC related things with smart contracts, then there's the Cosmosms channel you can go to. So I'll just grab some links and put them on the chat. Is that a good way to go?
Yes, that's a good way. You can just send the link to me or Lynn, and we'll put it out there for the devs.
Send the links to you and then you'll put it out there later.
Yes.
Okay, that's fine too. Yeah, that's totally good.
Yeah, or yeah, just for everyone, if there's any difficulty they're facing in, let's say, submitting their project or with the platform, feel free to reach out to us on Telegram. We are at DoraHacks Official, and I am also available to answer any question that you might have. I'm at Mishika Mishika 251 on Telegram or Twitter. Anything that works for you guys. Yeah, with that, we're also just one day from closing of the hackathon. So if you're on the last leg of your hackathon project, just finishing up your code, your product, I would suggest you to gear up and submit ASAP. We've already received a couple of super interesting projects, so going to be a close call. Yeah, that was it. If you have any questions, again, feel free to reach out. Lynn, we have the Discord link in the private chat. Please feel free to put it out in the YouTube live comment section.
Yeah, thank you so much for the time and the platform. I think it was really good, and in the future we'll have more workshops and IBC related content. So hopefully we can do this again later.
Perfect. Thanks a lot, Serdar. Thanks everyone for tuning in, and good luck for your projects. And yeah, like I said, submit it ASAP. Just one day remaining until we close the AEZ Boost Hackathon. So all the best to everyone who's building.